Hello, and welcome to today's lesson. We're going to be talking about how to analyze and solve problems with linear equations. So what that means is we're going to be given word problems, and we're going to have to take those word problems and write an equation and then solve that equation, which sounds like a lot, but we're going to be looking at how to break those down and how to look for key terms that help you to translate the words into an equation. And hopefully after a few examples, these will get easier for you. To also help these to not be as challenging, make sure that you're taking good notes. Always pause the video if you start going too fast so that you can get all the information down that you need to. And even copy down a few examples. That way it helps it to sink in. It's another action that you're doing by writing that helps this information to sink in. So I'm so glad that you are here to join us today, and let's go ahead and take some notes.
Being able to pick out keywords that we can translate into operations or an equal sign will help us to be able to write equations to solve and be more successful in these problems. So for addition, we have sum, more than, plus, added to, increased, and sum. The one that you need to watch out for is the more than, because more than means that you have to flip it. In the expression here, 5 is first, but in the written form, it's last. A number is second, over here, it's first. So you just have to keep in mind that when you see that than, that means you're going to be flipping the order. And that works for less than also. If you notice, the 3 is first, but it's last in the expression. In the verbal expression, a number is second, but it's first in the mathematical expression. So you just need to keep an eye out for that. And the other one in subtraction that will flip is subtracted from. Once again, a number is first, but the x is last. 6 is second, but it's first in the math expression. So just keep in mind those two tricks, and then you have all of the other numbers. You have multiplication, you have times, multiplied by, twice, of, a product. Those all mean you're going to be multiplying. In division, you have quotient, divided by, and ratio. And then anytime you see the word is, that means use an equal sign. We are going to be solving multi-step equations. And so the first thing you're going to need to do is to solve these is use the distributive property where necessary. So that means you want to get rid of the parentheses using the distributive property. Once you have that done, you're going to combine like terms. Then you're going to undo using addition and subtraction. And then you're going to undo using multiplication and division. And then you should have your variable by itself. The last bit of information that will make answering these problems easier is knowing how to calculate slope. So you can either calculate slope given a graph or given 2 points. If you're given a graph, you just need to calculate the rise over the run. And if you're given 2 points, you're going to subtract the y coordinates over subtract the x coordinates. So make sure you have all 3 of these slides copied down in your notes before you move on, so that you have these to reference back to when you're trying these problems. This problem here says Glenn has been training for a bicycle race. On Sunday, he covered a distance that was 3 miles more than what he usually covers. On the following Sunday, he covered 3 miles more than twice the miles he usually covers. He usually covers 5.3 miles. What is the total number of miles that he covered on the 2 Sundays? So this one here, you could write an equation, but you can also just work it out given the information that you have. So on the first Sunday, he covered a distance that was 3 more miles than what he usually covers. So more than means that I'm going to add 3 to what he usually covers. So he usually covers 5.3 miles. So I'm going to add 3 to that, and that's going to get me 8.3. Okay, so for the second Sunday, he covered 3 miles more than twice the miles he normally covers. So we have that more than, which is adding with a flip. So 3 is at the beginning in the words. It's going to be at the end. And then twice the miles he normally covers. Twice means to multiply by 2. So at the beginning, I'm going to have 2 times the normal number of miles, which is 5.3. So we do multiplication before addition. 2 times 5.3 is 10.6. Plus 3 is 13.6. So then just to find the total number of miles on the 2 Sundays, I'm going to have to add those two numbers. And 8.3 plus 13.6 is 21.9 miles. And that's going to be my final answer, which is B. Here's a question that says, Starla bought napkins at an outlet store for $3 each. And she also used a $15 off coupon. If Starla paid $66 before tax, how many napkins did she buy? This is an instance where writing down an equation and solving for x will be easier and shorter for you. So let's go ahead and look at all of the information that we are given. We know that she bought napkins for $3 each, and she used a $15 off coupon, and that she paid $66 before tax. So when I'm writing a linear equation, I'm going to have a number x plus or minus a number equal to the total. So I know my total here is $66. And so x is going to represent what I'm looking for, and what I'm looking for here is going to be the number of napkins. So what goes before x typically is a keyword each or per, because those mean multiplication, and you're multiplying this number here times x. And so the number here that I'm given with an each by it is $3. So that means I'm going to have $3 per the number of napkins, but she used a $15 off coupon. So she's going to subtract that from what she paid. So that means I'm going to have minus 15. Here is the number that happens once. You only take that coupon off once, unfortunately. And so that's why it's not by the x, because it only happens once. So that means I'm solving the equation 3x minus 15 equals 66. So I don't have any parentheses to remove. There's only one x, I don't need to combine any like terms, so I can move on to adding or subtracting. So I have a minus 15 on this side, so to undo that minus 15, I need to add 15 to both sides. You can draw this line down, the equal sign, to help you keep track of the left and right side. These 15s cancel, and I'm left with 3x equals 81. And then I need to divide both sides by 3. These 3's cancel, and I'm left with x equals, and 81 divided by 3 is 27. So that means my final answer here is going to be B. This problem says Erin is renting chairs and a tent for a party. She can rent from A1 Rental or Tonka Tents. A1 Rental charges $1.53 per chair, plus $62.56 for the tent. Tonka Tent charges $1.78 per chair, plus $58.81 for the tent. How many chairs will Erin need to rent for the cost of the rentals to be the same? So first up, let's go ahead and write down what we know for each company. So for A1 Rental, we know that they charge $153 per chair and $62.56 for the tent. And then for Tonka tents, which I abbreviated TT, we know that they charge $178 per chair and $58.81 for the tent. So first, let's write an expression for A1 rental. So that means I need to decide what number goes before X and what number goes added or subtracted after X. So before X, that number is being multiplied. So here, this is per chair. That's the reoccurring number. So that's going to be the number that is in front of X. And then it's an additional charge, one-time charge for the tent. So that one-time additional charge is going to go after X. And so that's my expression for A1 rental. And let's go ahead and do the same for Tonka tents. Tonka tents, I'm going to have that same per chair cost of $1.78. That number is also going to go in front of X. And then my one-time fee is also going to be added to X. So the types of numbers go in the same places. It's just that the numbers are different. So here, X represents how many chairs they need. And that's what I'm looking for. But I'm looking for when are they the same. So to know when they are the same, I have to set these equal to each other. So I set these equal to each other, and that's what I'm solving for. Now I'm going to be solving for X. So I'm going to have to combine like terms. I have an X on the left side and an X on the right side. So I'm going to go ahead and combine those by bringing all of the X's over to the left side. So that means I'm subtracting 1.78x from both sides. Here they equal out to 0, so they cancel. And on the left side, that equals negative 0.25, and then I have the plus 62.56 equals, and then over here I'm just left with the 58.81. So now I need to continue to get X by itself, so I'm going to subtract 62.56 from both sides. And this cancels out to 0, so I'm just left with negative 0.25x on the left. And then on the right, I'm left with negative 3.75. My last step here is going to be to divide both sides by negative 0.25. And when I do that, these cancel out and I'm just left with x. And then when I do the division on the left side, that gives me 15. So that means if I buy 15 shares in a tent from each company, it's going to end up costing me the same. So that means my final answer here is C. The table above shows the cost of going to the state fair. There's an admission fee and a separate charge for each ride, all of which have the same price. Based on the information in the table, what is the price per ride? So, looking at the table, I see if I don't have any rides, I still pay the $15 to get in. So that means that $15 is going to be that one-time admission fee. And then if I go to 2 rides, that's going to cost me $19. 4 rides cost me $23, and so on. So if I want to find out what one ride costs, first I'm going to have to look, I'm going to take this $19 and I'm going to subtract off the admission fee. So that leaves me with $4. But that $4 is for 2 rides. So how much does each ride cost? You're going to take 4 divided by 2, which is 2. So that means it's $2 per one ride. So here, what you ended up finding was the slope of that table. And you're able to do this one without setting up an equation. So your final answer here is going to be C. The next problem here says Lauren went to a store to buy some clothes. The shirts were selling at a 20% discount. A pair of pants cost $5 less than 3 times the original cost of the shirt. If she spent $36 in all. What was the original cost of the shirt? So I'm looking for the original cost of the shirt. So I'm going to make that X. That's what I'm solving for. And now I'm going to look at what else I have in this problem that I know. So I know that the shirts were at a 20% discount. And then I know that the pants were $5 less than 3 times the original cost of the shirt. So I'm going to write an expression for the cost of the shirt and then an expression for the cost of the pants. So the shirt was 20% off. So that means I paid 80% of the original price. So you saved 20%, but you paid 80%. So I'm going to write this as 0.80, so 80% is a decimal, times the original cost of the shirt, which is X. And then I need to write an expression for the pants. The pants cost $5 less than. So that means I'm going to be subtracting, but there's going to be a flip. So 5 is in front of the less than. It's going to be after the subtraction symbol. 3 times the original cost is after than, so it's going to be in front of the subtraction symbol. So 3 times means 3 multiplied the original cost of the shirt, which we said is X. And for her shirt and for the pants, she spent $36 in all. So that means to find the original cost of the shirt, I'm going to have to add these together and set it equal to 36 and then solve for X. So here I have X's on the same side of the equal sign. So since they're on the same side, I'm going to add them together, keeping the same sign. So 3 plus 8.80 is going to be 3.8x. And then I still have the minus 5 equals 36. And I go ahead and continue to solve this. So I'm going to separate my left and right side. My next step is going to be to add 5 to both sides. These 5's cancel. And I'm left with 3.8x equals 41. And then I'm going to divide 3.8 from both sides. These cancel and just leave me with x. And then the division on the right side turns out to be 10.79 is what it rounds to. And we're working with money, so that's why I went to 2 decimal points. And so that means the original cost of the shirt was $10.79, which is B. This example says Don, Keith, and John are all working on a history project. Don spent 1.2 hours less than 5 times as many hours on the project as John did. He spent 0.8 hours more than 4 times as many hours on the project as John did. If Don and Keith spent the same amount of time working on the project, how many hours did John spend working on the project? So first we're going to say what our X represents. And so since we're looking at how many hours John spent working on the project, we're going to go ahead and make that X. And if you look, that works out because they talk about how many hours they did in respect of what John did also. So there's our X's. All right, so first let's look at what we know about Dawn. She spent 2 hours less than 5 times as many hours as the project as John did. So first I see this less than. And less than tells us we're going to have to flip, and it's going to be subtraction. So for Dawn, I'm going to have subtraction. I'm going to put my subtraction symbol. And in the beginning of the written is 1.2. So in my math expression, it's going to be after the subtraction symbol. Then after less than in the written is 5 times as many hours as John did. So the hours that John spent is X. So 5 times X, or 5X, is going to go at the beginning here. And then I need to do the same thing for Keith. Keith spent 0.8 hours, more than 4 times as many hours on the project as John did. So I have this more than, which works like less than. It's going to be a flip, only it's addition. And 0.8 hours, 0.8 was at the beginning in the written, so that's going to be at the end in my math expression. And then 4 times as many hours as John did, or X, so 4 times X, or just 4X. And then it tells us that Dawn and Keith spent the same amount of time working on the project. So that means that these two expressions here are equal to each other. And so I can set them equal to each other and solve for X to get my answer, which looks like this. So the first thing I'm going to do is get my X's on the same side of the equation. So I'm going to go ahead and draw a line so that I can see the difference between them. And because the X's are on different sides of the equation, I'm going to have to subtract 4X from both sides. So over here, these X's cancel. And 5X minus 4X, I'm just left with that single X minus 1.2, and that equals 0.8. And then I need to add 1.2 to both sides. On the left side, the 1.2s are going to cancel out to 0, and I'm just left with X equals 2. So here, John spent 2 hours on the project, which is choice A. The C problem here says the equation y equals 3x describes the relationship of the temperature of a gas and volume, where x is the temperature and y is the volume. Which graph below matches this equation? So I have the equation y equals 3x. If you notice, there's no number being added or subtracted by itself, so you can fill in a plus 0. We just don't write it because adding 0 doesn't change anything, so it's not necessary. So that is going to be our y-intercept. And when I look at all of my answer choices, these all start at 0, so it doesn't help eliminate anything. So I'm going to have to look at the slope. And so the number in front of x is going to be my slope number. And I can find the slope by counting rise over run on each of these examples. And when I'm counting, though, I need to be mindful of the scale that they're using for each box. So W here, the scale is each of these little blocks is 25. So 0, 25, 50, 75, 100 on the y-axis. And on the x-axis, it's 5, 10, 15, 20, 25, 30, etc. So I need to count by 25 and 50 when I'm counting my rise over run. So for W, I'm going to count these boxes, and I'm going to count up for my rise first. So 25, 50, 75 is my rise, and then my run is 5, 10, 15, 20, 25. And then I need to simplify that down. 75 over 25 equals 3. And 3 is the slope that I'm looking for. So it looks like W is going to be my answer. To look at 1 so you can see how a wrong answer works, let's look at Z. So once again, I have the same scale on the y and x axis. And so here I'm going to count up by 25. So 25, 50, 75, 100, 125. And then I need to count by 5s on my run. So 5, 10, 15, 20, 25. And that reduces to 5, which is not my slope. So W is going to be my final answer, which is choice A. Thank you for joining us today, and I hope you learned something new.